The universe is full of stars, hundreds of billions in our galaxy alone, trillions more beyond. Many of them are older than our sun, many of them have planets, and some of those planets should have produced life, intelligent life, civilizations with millions of years of head start on us. And yet, when we listen, there is nothing, no signal, no transmission, no whisper, only silence. A silence so vast that it has a name: the Great Silence. In 1950, a physicist named Enrico Fermi sat down to lunch and asked a simple question: where is everybody? Tonight we follow that question somewhere darker, a place with a name: the Dark Forest. Welcome to Strindberg's Space Stories. If you enjoy these journeys, subscribing truly helps others find their way here too. So, settle in, let your breathing slow. This story is quiet, but it is not entirely comforting. Fermi's lunch took place at Los Alamos National Laboratory in New Mexico. The group included Edward Teller, Herbert York, and Emil Konopinski, all physicists working at the laboratory where, just 5 years earlier, the first nuclear weapons had been built. The conversation that day had started with flying saucers. A recent New Yorker cartoon depicting aliens stealing public dustbins had prompted jokes about extraterrestrial visitors. The mood was light, and then Fermi asked his question, half joke and half thunderbolt. His colleagues laughed, but Fermi was not entirely joking. He had done some mental arithmetic, the kind of quick back-of-the-envelope calculation for which he was famous, and the numbers troubled him. The question was not casual. It was the distillation of a profound observation about the age and size of the universe, the probability of a life, and the conspicuous absence of any evidence that anyone else is out there. The question sounds casual. It is not. Behind it lies a calculation that is genuinely unsettling. In 1961, the astronomer Frank Drake formalized the reasoning behind Fermi's question in what became known as the Drake equation. It is not really an equation in the mathematical sense. It is a framework, a way of organizing everything we do not know into a single line of factors multiplied together. How many stars form in the galaxy each year? What fraction have planets? What fraction of those planets develop life? What fraction of that life becomes intelligent? What fraction develop technology? And how long those technological civilizations last before they go silent, whether by choice, by catastrophe, or by extinction. Even the most conservative estimates, plugging in the most cautious numbers for each factor, produce results that are difficult to ignore. Our sun is roughly 4.5 billion years old, but the universe is nearly 14 billion. There are an estimated 200 billion to 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. Many of those stars are billions of years older than ours. Even if intelligent life is fantastically rare, arising on only one planet in every 10 billion, there should still be millions of civilizations in the observable universe. Some of them should be millions or even billions of years more advanced than us. A civilization with a million-year head start on humanity is almost impossible to imagine. Consider that we went from the first powered flight to landing on the moon in 66 years. From the first computer to artificial intelligence in less than a century. Now multiply that pace of development by 1 million years. Such a civilization would possess technology so far beyond ours that it would appear, to us, indistinguishable from magic. They should have colonized the galaxy by now. Even at speeds far slower than light, using generation ships or self-replicating probes, a single civilization could spread across the entire Milky Way in a few tens of millions of years. A blink on cosmic timescales. They should have built structures we could detect. They should have reshaped entire star systems. At the very least, we should have heard something, a signal, a transmission, an electromagnetic whisper from across the void. We have heard nothing. 65 years of listening with radio telescopes, decades of scanning the sky for laser pulses, infrared anomalies, Dyson spheres, megastructures, artificial signals of any kind. The SETI program has searched millions of star systems. Nothing. The universe, as far as we can tell, is silent. Not quiet. Silent. The absence is not subtle. It is, in the words of the physicist Paul Davies, eerie. This is the Fermi Paradox, and it has many proposed solutions, each one uncomfortable in its own way. Perhaps life is rarer than we think. The conditions required for biology may be so specific, so dependent on a precise combination of chemistry and temperature and planetary stability, that it has arisen only once in the entire observable universe. This is called the rare Earth hypothesis, and if it is correct, the silence is simply the sound of an empty galaxy. There is no one to hear because there is no one to speak. Perhaps intelligence is rarer still. Life may be common, but the leap from single-celled organisms to technology-building civilizations may require such an improbable chain of evolutionary accidents, the right mutations, the right pressures, the right catastrophes at the right times, that it almost never happens. Earth may be typical in having life, it may be unique in having minds. Perhaps civilizations inevitably destroy themselves. This is the great filter hypothesis, and it is one of the most discussed ideas in the field. The argument is that somewhere between the origin of life and the development of interstellar communication, there is a barrier, a filter, that almost no civilization passes through. It might be nuclear war, it might be climate collapse, it might be artificial intelligence that outgrows its creators, it might be a biological catastrophe, a pandemic so severe that it destroys the social structures necessary for technological civilization to persist. If the great filter is behind us, if it is something that Earth has already passed through, then we are rare and lucky. If the great filter is ahead of us, then our future is short. The silence, in that case, is the sound of civilizations that burned bright and then went dark, one after another, across the history of the galaxy. A graveyard of potential. Perhaps we are being observed. The zoo hypothesis suggests that advanced civilizations are aware of us, but choose not to interfere, treating Earth as a nature reserve or a laboratory, watching our development without making contact. Perhaps there is a galactic convention, an agreement among elder civilizations to leave young species alone until they reach a certain threshold of maturity. It is a comforting idea. It is also untestable. But there is one answer that is worse than all the others, not because it is the most likely, but because of what it implies about the fundamental nature of the universe we live in. It is called the dark forest theory, and it suggests that the silence is not an absence of civilizations. It is a strategy, a survival strategy, one that every civilization in the universe has independently adopted because the alternative is annihilation. The theory takes its name from a Chinese science fiction novel called The Dark Forest, written by Liu Cixin and published in 2008. It is the second book in the Remembrance of Earth's past trilogy, which begins with The Three-Body Problem, a novel that won the Hugo Award and became one of the most influential works of science fiction of the 21st century. The trilogy has been translated into dozens of languages and adapted into a major television series. Its central ideas, particularly the dark forest theory, have entered mainstream scientific and philosophical discussion in a way that few works of fiction ever achieve. The theory is presented not as a scientific hypothesis in the traditional sense, but as a logical conclusion reached by a fictional character, a quiet, unassuming sociologist and former astronomer named Luo Ji, who derives it from two axioms, two assumptions about the nature of civilizations in the universe. They are simple, almost obvious, and they lead somewhere terrifying. Axiom 1. Survival is the primary need of every civilization. Axiom 2. Civilizations continuously grow and expand, but the total matter and energy in the universe remain constant. These are not controversial statements. They are in fact almost tautologically true. Any civilization that does not prioritize its own survival will cease to exist. And the resources of the universe, vast as they are finite. Stars burn out, planets are depleted, energy is not infinite. Over long enough timescales, civilizations that expand will compete for resources, not necessarily today, not necessarily tomorrow, but eventually. From these two axioms, combined with the vast distances of space and the impossibility of truly knowing another civilization's intentions, the theory derives its conclusion. And the conclusion is this. The universe is a dark forest. Every civilization is an armed hunter, stalking through the trees like a ghost, gently pushing aside branches that block the path, trying to tread without sound. Even breathing is done with care. The hunter must be careful because the forest is full of other hunters just like him. He does not know where they are. He does not know how many there are. He does not know what weapons they carry or what they want. He knows only two things, that they exist, and that in the darkness, with no way to communicate, no way to negotiate, no way to verify intentions across distances measured in light years and timescales measured in millennia, the safest strategy is the simplest one. Silence, and if you detect another hunter, elimination, before they can eliminate you, not because you want to, because the logic of the forest leaves no other choice. The logic is built on a concept that Liu Cixin calls the chain of suspicion. It is, in essence, a cosmic version of the prisoner's dilemma, but with one critical difference. In the classic prisoner's dilemma, the game is played once or repeatedly between two known parties. In the dark forest, the game is played between strangers who cannot communicate, cannot verify, and cannot predict each other's future behavior. The stakes are not prison sentences. They are extinction, and the game is played only once. Imagine two civilizations become aware of each other across interstellar space. Call them A and B. Civilization A detects a signal from Civilization B. Perhaps it is a radio transmission. Perhaps it is the spectral signature of an industrialized atmosphere. Perhaps it is nothing more than a faint anomaly in a survey, a data point that might be natural or might be artificial. What should A do? A does not know whether B is friendly or hostile. Even if B transmits a message of peace, beautifully composed, rich in mathematics and goodwill, A has no way to verify it. Intentions can be concealed. Diplomacy can be a mask. And across the vast distances of space, where a reply takes years or decades or centuries to arrive, there is no way to build the kind of trust that requires sustained, real-time interaction. A cannot visit B to shake hands. A cannot inspect B's weapons. A cannot monitor B's behavior over time in any meaningful way. A can only guess. And guessing, when the penalty for guessing wrong is the annihilation of your entire species, is not a strategy. It is a gamble. But it gets worse. Even if A believes that B is currently peaceful, A cannot know what B will become. Civilizations change, governments fall, ideologies shift, technologies advance. A civilization that is peaceful today may not be peaceful in 1,000 years or 100,000, and 100,000 years is nothing on cosmic timescales. It is less than 1% of 1% of the age of the universe. The question is not whether B is dangerous now, it is whether B could ever become dangerous, and the answer, for any civilization capable of growth and technological development, is always yes. And it gets worse still. Even if A decides that B is harmless, that B will probably remain harmless, A must consider the possibility that B is having the same thought process about A. B is also uncertain, B is also afraid, and B, reasoning along the same lines, looking at the same incomplete information, feeling the same existential dread, might decide to strike first, not out of malice, out of fear, out of the rational calculation that the risk of being wrong is too great. A knows this, and B knows that A knows this, and A knows that B knows that A knows. The suspicion cascades, each layer reinforcing the last, each escalation making the next more likely, until the only rational conclusion for both sides is that the other represents an existential threat that must be neutralized before it can act. This is not paranoia. This is not a failure of imagination or a deficit of empathy. It is a structural feature of the universe. The distances are too great, the timescales are too long, the information is too incomplete, and the cost of being wrong is too absolute. Trust, the kind of trust that arises between individuals who can look into each other's eyes and read each other's intentions and verify each other's actions over time, simply cannot exist between civilizations separated by light years of empty space and millions of years of divergent evolution. And without trust, the chain of suspicion is unbreakable. There is one more element that makes the dark forest particularly deadly. Liu Cixin calls it the technological explosion. It is the idea that civilizations do not advance at a steady, predictable pace. They advance in bursts, in explosions, in sudden, unpredictable leaps that can transform a species from harmless to dangerous in what amounts to an instant on cosmic timescales. Consider humanity. 250 years ago, the fastest mode of transport was a horse. 200 years ago, we had no electricity. 150 years ago, we had no telephone. 100 years ago, we had no antibiotics. 75 years ago, we had no computer. 50 years ago, we had no internet. 30 years ago, we had no smartphones. 15 years ago, we had no deep learning. The pace of technological change is not linear. It is not even exponential in a smooth, predictable way. It comes in surges, in revolutions, each one building on the last, each one arriving faster than the one before. A person born in 1900 lived to see the horse and cart replaced by commercial air travel, nuclear weapons, satellites, and a human footprint on the moon. No model available in 1900 could have predicted any of it. Now, project this onto a cosmic stage. A civilization detected today might appear to be primitive, pre-industrial, harmless, barely worth noticing. But within a few centuries, a heartbeat in cosmic terms, it could undergo its own industrial revolution, its own nuclear age, its own digital transformation, its own artificial intelligence revolution, and emerge as a civilization capable of interstellar travel, energy harvesting on a stellar scale, and weapons that can sterilize a planet from light years away. The window between harmless and existentially dangerous may be vanishingly small. 1,000 years, a few hundred, perhaps less. By the time the threat is obvious, it may be too late to act. This means that a more advanced civilization, observing a younger one, cannot afford the luxury of patience, cannot afford to wait and see how they develop, cannot afford to assume that a species that seems peaceful today will remain peaceful through its technological adolescence. The only safe strategy, the only one that eliminates the risk entirely, is to act while the younger civilization is still small, still broadcasting its position, still naive enough to send golden records into the void with maps to its home, still young enough to believe that the forest is safe. The dark forest theory does not require malice. That is perhaps the most disturbing thing about it. It does not imagine evil empires plotting galactic conquest. It does not require hatred or cruelty or ideology. It imagines rational actors, behaving logically, acting on incomplete information, in a universe where the stakes are absolute and the margins for error are zero. The logic is cold, impersonal, mathematical. And it leads to the same conclusion regardless of the species, the biology, the culture, or the moral philosophy of the civilization involved. In a dark forest, it does not matter whether you are good or evil, kind or cruel, peaceful or warlike. It only matters whether you are seen. Which brings us to an uncomfortable fact about our own species. We have not been quiet. We have not been quiet at all. Since the early 20th century, humanity has been leaking electromagnetic radiation into space. Radio broadcasts, television signals, radar pulses, military communications, all radiating outward from Earth at the speed of light, forming an expanding bubble of detectable noise that now extends roughly 120 light-years in every direction. Within that bubble are thousands of star systems. Any civilization with a sufficiently sensitive receiver, a radio telescope not dramatically more advanced than the ones we already possess, could, in principle, detect our presence. We have been making noise in the forest for over a century, and we have done more than leak. We have shouted, deliberately, repeatedly, with increasing enthusiasm. In 1974, astronomers used the Arecibo radio telescope in Puerto Rico to transmit a powerful, focused message toward the globular cluster M13, a dense ball of roughly 300,000 stars about 25,000 light-years away. The Arecibo message was a string of 1,679 binary digits, arranged in a grid that, when decoded, depicted information about our number system, the chemical elements of life, the structure of DNA, a stick figure of a human being, a diagram of our solar system, and a representation of the Arecibo dish itself. It was a business card, broadcast at 3 trillion watts of effective radiated power, aimed at 250,000 stars. It will arrive in about 25,000 years. If anyone is there, and if they are listening, they will know where we are and what we look like. In 1977, NASA launched the Voyager 1 and Voyager 2 spacecraft, each carrying a golden record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. The record included greetings in 55 languages, music from Beck to Chuck Berry, the sound of a kiss, the sound of rain, the brainwaves of a young woman in love, photographs of humans and animals and landscapes, and diagrams showing our position in the galaxy relative to 14 pulsars. Those pulsar positions are a map, a precise, verifiable, unmistakable map. Any civilization that finds the Voyager probe and decodes the record will know, to a high degree of accuracy, exactly where in the Milky Way to find us. The record was assembled by a committee led by Carl Sagan, one of the most optimistic and most eloquent voices in the history of science. Sagan believed profoundly that any civilization capable of interstellar travel or communication would be, by necessity, peaceful. His reasoning was that aggressive civilizations destroy themselves before they can reach the stars, filtered out by their own violence, leaving only the wise and the cooperative. It is a beautiful argument. It may even be correct, but it is not certain, and the golden record with its pulsar map is drifting through interstellar space right now, carrying our address to anyone who finds it. In 2017, the organisation METI International transmitted a signal toward Luyten's star, a red dwarf just over 12 light-years away with a potentially habitable planet in its system. The signal contained mathematical and scientific information. It will arrive around 2029. Other transmissions have been sent toward the TRAPPIST-1 system and various nearby stars. Each one carries information about our existence and, implicitly or explicitly, our location. Stephen Hawking warned against all of this, repeatedly. In 2010, and again in 2015, and again in 2016, Hawking cautioned publicly against active attempts to contact extraterrestrial civilizations. He supported listening, he supported the search, but he opposed broadcasting. His reasoning was blunt and rooted in the history of our own species. If aliens visit us, he said, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. He noted that any civilization reading one of our messages could be billions of years more advanced and might not see us as any more valuable than we see bacteria. If the dark forest theory is correct, every one of these transmissions was a mistake. Every signal we have sent, every map we have included, every cheerful greeting we have broadcast into the void, was the equivalent of lighting a bonfire in the darkest part of the forest and shouting, "Here I am." It is important to say clearly that the dark forest theory is not established science. It is a thought experiment, a logical argument derived from a set of assumptions that may or may not reflect reality. It is compelling. It is internally consistent. But it is not the only possible answer to the Fermi Paradox, and not everyone accepts its premises. The first and most common objection is that the theory assumes the worst about every possible civilization in the universe. It takes the darkest possible reading of interstellar relations and universalizes it. In game theory terms, it treats every interaction as a one-shot prisoner's dilemma played under conditions of total ignorance. But in the real world, the prisoner's dilemma does not always end in mutual betrayal. Human societies, despite centuries of war and exploitation, have also produced cooperation, diplomacy, trade, and institutions designed to build trust between strangers. The United Nations, international treaties, trade agreements. These are imperfect, often fragile, but they exist. They demonstrate that rational actors can find ways to cooperate even when mistrust is high. Perhaps interstellar civilizations could do the same. The dark forest proponents respond, the analogy breaks down at interstellar distances. On Earth, trust is built through proximity, through repeated interactions, through the ability to verify compliance and punish defection. You can inspect a neighbour's weapons. You can monitor their military activity by satellite. You can trade with them today and observe whether they honour the agreement tomorrow. None of these conditions exist between civilizations separated by light years. There is no repeated game because each exchange takes decades or centuries. There is no enforcement mechanism because no one can project force across those distances quickly enough to prevent a first strike. And there is no way to verify that a promise of peace will be kept for 1,000,000 years. The conditions that make cooperation possible on Earth do not scale to the cosmos. A second objection is that the theory assumes all civilizations are expansionist. Perhaps some are content to stay home. Perhaps some have turned inward, exploring virtual realities more interesting than the physical universe. Perhaps some have transcended the need for material resources entirely, existing as pure information, as patterns in the quantum foam, as something so far beyond our comprehension that the concept of competition for resources is as meaningless to them as it would be to us to compete with bacteria for sunlight. If civilizations can outgrow the need for expansion, the second axiom collapses, and the dark forest with it. A third objection is practical. If a civilization is advanced enough to detect another across interstellar distances and to launch a strike capable of destroying it, then it's presumably also advanced enough to observe without being detected. Sterilization is not cost-free. It requires energy. It requires technology. It requires the willingness to commit what amounts to genocide against a species you know nothing about. And it carries a risk. The act of striking might itself reveal your position to other watchers. A sufficiently advanced civilization might decide that observation is safer than destruction, that gathering information is more valuable than eliminating a potential threat. The galaxy, in this reading, might be full of watchers, not hunters. A neighbourhood of civilizations peering at each other through telescopes, aware of each other's existence, choosing not to act. And there is the argument from our own continued existence. Humanity has been broadcasting electromagnetic radiation for over a century. Our most powerful transmissions, radar signals bounced off the moon and planets, military early warning systems, the Arecibo message, are detectable at distances of hundreds or thousands of light years by a civilization with technology comparable to our own. If the forest is as dangerous as the theory suggests, and if there are hunters within 100 light years, why are we still here? Several answers have been proposed. Our signals may not have reached anyone yet. 100 light years is a small distance on a galactic scale, and the density of civilizations may be low enough that none exist within range. Or we may be too primitive to be considered a threat. A civilization that has not yet left its own planet, that is still burning fossil fuels and arguing about climate change, is hardly worth the cost of an interstellar strike. Or, more unsettlingly, we may have been noticed, and a response may be on its way, travelling at some fraction of the speed of light across the void, and we will not know until it arrives. The dark forest theory is not really about aliens, not at its deepest level. It is about trust, about the fundamental, perhaps unsolvable problem of establishing cooperation between minds that cannot verify each other's intentions. On Earth, trust is built through a web of mechanisms so familiar that we rarely think about them. Eye contact, body language, tone of voice, shared meals, handshakes, contracts, courts, borders, armies, mutual assured destruction. These are not elegant solutions. Some of them are ugly, but they work more or less because they allow strangers to interact without full knowledge of each other's intentions, substituting verifiable structures for unverifiable goodwill. We do not trust each other because we know each other's hearts. We trust each other because we have built systems that make betrayal costly and cooperation rewarding. None of these systems exist in interstellar space. There is no handshake across 40 light years. There is no treaty that can be enforced when the nearest court is in another solar system. There is no mutual assured destruction when the speed of light imposes a decades-long delay on every action and reaction. The tools that humans have used to build trust, the entire infrastructure of cooperation that allows 8 billion people to coexist on a single planet without annihilating each other every Tuesday. All of it depends on proximity, on speed, on the ability to act and respond within a shared time frame. Remove those conditions, and trust becomes not merely difficult but structurally impossible. The forest is dark because information is incomplete, because the cost of being wrong is extinction, because the distance between intention and perception is measured not in miles, but in the impossibility of ever truly knowing what another mind is thinking, when that mind is separated from yours by light years and millennia, and an evolutionary history that shares no common ancestor. The theory takes the deepest problem of human social life, the problem of trust between strangers, and projects it onto a canvas the size of the universe. And on that canvas, stripped of every mechanism we have ever invented to manage our fear of each other, the answer it gives is the bleakest one available. Trust is impossible. Silence is the only safety. And the first civilization to speak is the first to die. Whether this is the correct explanation for the Fermi Paradox, no one knows. It may be that life is rare and we are effectively alone. It may be that civilizations destroy themselves and the silence is a graveyard. It may be that the galaxy is full of peaceful beings who would welcome us warmly if only we could find them. We do not know. We have no data. We have only the silence. And the silence, maddeningly, is compatible with all of these explanations, including the one that says the silence is itself the message, the one that says, be quiet, stay hidden, do not light the fire, the forest is listening. There is a version of the dark forest that is even darker than the one Liu Cixin describes. It does not require hunters, it does not require weapons. It does not require strikes or sterilizations or relativistic kill vehicles launched across the void. It requires only the logic of the theory itself, spread across enough civilizations for enough time to produce a galaxy-wide silence through nothing more than fear. If every civilization that arises in the galaxy independently reaches the same conclusion, that broadcasting is dangerous, that silence is the only safe strategy, that the risk of detection outweighs the benefit of contact, then the silence we observe is not the result of anyone being destroyed, it is the result of everyone being afraid. The forest is quiet not because the hunters have killed all the prey, but because every creature in the forest, every one of them, has independently concluded that making a sound is the most dangerous thing it could possibly do. In this version, the galaxy could be full of life, full of civilizations, full of minds as curious and as lonely and as desperate for contact as we are. Millions of them, billions perhaps, all of them watching, all of them listening, all of them waiting for someone else to go first. And none of them willing to take the risk. A galaxy of civilizations, each one crouching in its own corner of the dark, holding its breath, surrounded by neighbors it can neither see nor hear nor trust, each one alone. Not because it has to be, not because the universe requires it, but because the logic of the forest says that being alone is the only way to be safe. The silence in this reading is not a puzzle to be solved. It is a choice being made, right now, by everyone, everywhere, including perhaps civilizations so close to us that their light reaches our telescopes every night, their planets visible in our surveys, their chemistry detectable in their atmospheres. They may be there, they may know we are here, and they may have decided long ago that the safest thing to do about us is nothing at all. That may be the loneliest idea in the history of human thought. And yet, we sent the Voyager records, we transmitted the Arecibo message, We beam the Beatles toward Polaris. We carve diagrams on golden plaques and launch them on trajectories that will carry them past the nearest stars in 40,000 years. We did this knowing the risks, or at least suspecting them. Stephen Hawking warned us. The logic of the dark forest warned us, and we did it anyway. There is something defiant in that. Something that the dark forest theory, for all its logical rigour, does not fully account for. The theory assumes that survival is the primary need of every civilization. And perhaps it is. Biologically, evolutionarily, practically, the drive to persist is fundamental. But humans have a long and well-documented history of doing things that are not strictly necessary for survival. We build cathedrals that take centuries to complete. We write symphonies that no one will hear until we are dead. We send messages into space that will not arrive for thousands of years. We plant trees whose shade we will never sit in. These are not survival behaviours in any narrow Darwinian sense. They're acts of faith, acts of hope, acts of a species that refuses to be defined entirely by the calculus of self-preservation. Carl Sagan, who assembled the Voyager Golden Record, understood this. He knew the risks. He had read the arguments. He was not naive. But he chose to send the record anyway, because he believed that the act of reaching out, of introducing ourselves to the unknown, was worth the risk. The launching of this bottle into the cosmic ocean, he wrote, says something very hopeful about life on this planet. He believed that the desire to communicate, to share, to connect across the void was one of the best things about being human, and he was willing to bet the species on it. The dark forest may be right. The silence may be a warning. The wisest course of action may be to say nothing, build nothing visible, shield our electromagnetic emissions, and hope that no one has noticed us yet. Some scientists have seriously proposed exactly this: minimize our radio leakage, stop transmitting deliberate signals, treat the cosmos as hostile until proven otherwise. Or the dark forest may be wrong. The silence may have a simpler, less terrifying explanation. Life may be rare. Intelligence may be precious. And we may be among the first to speak, not because everyone else is hiding, but because no one else has arisen yet. The universe is young. Our galaxy is only halfway through its life. Perhaps we're not late to the party. Perhaps we are early. And the forest is not dark because it is dangerous. It is dark because the other lights have not been lit yet. Either way, the question remains. The same question Fermi asked over lunch at Los Alamos in the summer of 1950. The same question that children ask when they look up at the stars. The same question that sits at the centre of every story we've ever told about the sky, from the myths of ancient Greece to the science fiction of Liu Cixin. Where is everybody? Maybe your eyes are heavy now. Maybe the room has gone still. But above you, if the sky is clear, the stars are out. Hundreds of them visible to the naked eye. Thousands with binoculars, each one a sun, many of them older than ours, some of them orbited by planets that have had billions of years more than Earth to produce something that thinks and wonders and fears. And all of them are silent. Maybe they are not there. Maybe life is so rare, so improbable, so dependent on a chain of coincidences, so long and so unlikely, that we're the only minds in a galaxy of 400 billion stars. That would make us precious beyond measure, the only light of consciousness in 100,000 light years of darkness, alone, not because anyone is hiding, but because no one else was ever born. Or maybe they are there, all of them, crouching in the dark, watching the sky, listening for a sound, too afraid to make one. Maybe the forest is full, and every star you see tonight has someone looking back, wondering the same thing you are wondering right now. Wondering whether it is safe to speak. Wondering whether the silence is a warning or an invitation. Wondering whether the next signal they detect will be a greeting or a targeting solution. We spoke. We sent our music and our mathematics and our maps and our greetings in 55 languages into the void. We lit our bonfire in the forest and called out to anyone who could hear. Whether that was brave or foolish, no one alive today will ever know. The answer's out there, travelling toward us at the speed of light, or it is not. The forest is dark or it is empty, and either way, we are here. On this small, noisy, luminous, reckless planet, the only world we know of that has ever looked up at the night sky and refused to be silent. Thank you for listening to Strindberg's Space Stories. If this story gave you something to carry into the night, subscribing truly helps us keep making these, and I am grateful for every one of you who does. Take care of yourself. Sleep well. Good night.